take y for fx, then for 0 this is 2, 1, 2, 2, 2, 3, 2. This is 0, that means value of the function is also 2, means I Good afternoon to my students, learners. Actually today I am going to start first class for class 12. I am going to start the topic continuity and differentiability. Actually the syllabus is framed keeping in mind that it will be the continuity of the topics learned in class 11. That is why continuity. This topic continuity is deeply connected with the topic limit, which was discussed in class 11. That is why I am to first recapitulate or revise the matter of limits. If x tends to a, then the limiting value of the function fx is, say, L, will happen if limit x tends to a minus fx, limit x tends to a plus fx. Also we call this one LFA, left hand limit of the function fx is equal to RFA. Also we express by writing f a minus 0, f a plus 0. And this L is a finite number. Fx be a function, then the limiting value of fx will exist if limit x tends to a minus fx, that is left hand limit of the function, is equal to limit x tends to a plus fx, that is right hand limit of the function, that is equal to L, a finite number. These were discussed in class 11. Then the definition of the limiting value of fx was discussed, and it was for a pre-assigned epsilon, which is positive number, however small, there exists a delta which is function of epsilon such that this was the analytical definition for the existence of limit of the limit extends to a if x equal to L. It was discussed earlier. Then we discussed the geometrical approach by drawing graph then some standard limits I write here few limit x tends to a x to the power n minus a to the power n x minus a divided by is equal to a to the power n minus 1 limit x tends to 0 sin x by x equal to 1 limit x tends to 0 log of 1 plus x divided by x equal to 1 limit x tends to 0 e to the power x minus 1 x equal to 1. These were the standard limits and a few theorems also related to limits discussed. After that we worked out lot of sums on the topic limit. Next come continuity. First let us try to understand the meaning of the term continuity in practical life. If I say it is raining or it has been raining for say 2 hours continuously, what is the general meaning? That means there is no instant in between those specific 2 hours when there was no rain. Hence, we can say meaning of continuity as no break or no gap. Let us clarify by taking. Now this term is used in mathematics. To understand that, let me take one example. And with the help of drawing graph, we shall try to understand. I have taken the function if x is equal to 2 when x is greater than or equal to 0, minus 1 when x less than 1. Let us draw the graph. I take y for fx, then for 0 this is 2, 1, 2, 2, 2, 3, 2. When x less than 0, fx equal to minus 1, therefore if we make the chart, that will be less than 0. That is why I take minus close to the origin. Thus, two tables have been framed. Now, we draw the graph. For x equal to 0, 2, therefore I name this point as A, say B, and C, D. AB ray represents fx equal to 2 or y equal to 2 when x is greater than equal to 0. CD ray represents y equal to fx when x less than 0. Here C is excluded Here we can write the coordinates of A. Now from the graph it is clear, as x tends to 0, LF0 is equal to RF0 is to LF0 is minus 1. Two limiting values, left hand limit, right hand limit, both are different. Thus we see also there is a break or gap at the point x equal to 0. That means from the graph it is clear that as limit x tends to 0, limiting value of x does not exist. Now let us take another example. Both having the same value 2, as x positive as x negative. Now if I draw the graph will be that y equal to fx. Therefore y equal to 2 as x positive, y equal to 2 as x negative. Now if we exclude that with the help of this graph, then y equal to 2 is represented by AB ray, where A is excluded 0 to y is equal to 2. I mention here is represented by CD ray where C is excluded 0. But we find L if 0, left hand limit, that is 2, also right hand limit, that is 2. So, according to the concept of limit, limiting value exists. Therefore, limit x tends to 0, fx equal to 2. But if we try to draw the graph, the question is, can we draw the graph without lifting the tip of the pen or pencil at x equal to 0? The answer is no. We have to lift the pen or pencil, rather tip of the pen or pencil, to draw the graphs of this given function. Now, if it is mentioned that f0, that means value of the function is also 2, means if it is given f0 is 2, that means value of fx when x equal to 0 is also 2. Then we could have drawn the graph of the function y equal to 2 or fx equal to 2 for all real values of x without lifting the pen or pencil. That means there was no break or no gap at x equal to 0 as well as for any positive or negative values of x. Then we use the term y equal to fx is continuous at the point x equal to 0. Y equal to fx is continuous y equal to fx is continuous at x equal to 0. Why? From this practical problem, what we find, limit x tends to 0 plus fx, that is equal to limit x tends to 0 minus fx, that is right hand limit equal to left hand limit equal to the value 2, also that is equal to f0. From this example, we can say the function fx will be continuous at the point x equal to a. Here we are discussing at a point. Therefore, fx is continuous at, say, x equal to a if left hand limit LFA is equal to RFA, right hand limit, that is equal to FA, value of the function at the point x equal to a. Thus, we get the condition of continuity of a function fx at the point x equal to a. Here, I have discussed the continuity of the function fx at x equal to a. Continuity of fx at the point x equal to